Lecture is in continuation with the last lecture of the block diagrams. So here we are going to discuss about the elimination of a summing point in a closed loop system. As you can see in the figure, we have the input Rs, the transfer function Gs, Hs is the transfer function of the feedback loop, okay, and Bs is the output of the feedback loop. Okay, we are comparing both the input Rs and the Bs at this emission point. Or you can see that the Bs, the reference of this is giving us the error in this closed loop. Okay, so you can see here that Bs will give you Cs into Hs. Okay, Cs Hs, okay, which is compared with Rs over here. Okay, and it gives the result Es. It gives the result Es when we are comparing this Bs with the Rs over here. All right. So Es is represented by, simply Es should be represented by Rs plus minus Bs. Okay. Okay. Let's move further. And let's see that from the block diagram you can see that the Cs is the output. Cs upon Es, Cs upon Es, which is the error, it will give you Gs. Okay, this is the transfer function. It's very easy. Gs is simply terms as the transfer function of the feed forward path. Gs is the transfer function of feed forward path. Okay, now in the feedback loop you can see that Bs is the output of the feedback loop. Bs upon Cs, this will give you Hs. This will give you Hs. Okay, which is the transfer function of feedback path. All right, and the output of the summation point will give you output of summing point. Es is equals to Rs plus minus Bs. Okay, now we are just going to do some let's put the value of Es and Bs. Okay, Es and Bs. Es is what? Es and Bs. From here let's put the value of Es and Bs. We will get Es is equals to what? Es you can see from here. Es is equals to simply Cs upon Gs, Cs upon Gs. Okay, then simply Rs is there plus minus Bs is there. Okay, Bs is simply what? Cs into Hs. Now you can see this, that the transfer function is simply what of this overall block is Cs upon Rs. Okay, so we need Cs upon Rs, which should be the transfer function. So we have in this equation as Cs upon Gs, so we need a bit of simplification. Cs is equals to, we just going to multiply this on the both side as Rs plus minus Cs into Hs. Okay, this will give you Rs Gs plus minus Cs Hs Gs. Okay, what we need? Cs upon Rs. Okay, so here is Cs and here is Cs. This will become Rs Gs is equals to CS plus minus CS HS GS. Okay, so from here CS upon RS will give you GS divided by 1 plus minus HS to GS. This is the overall transfer function of the above block diagram. Okay, so as you can see that, we are just going to represent or reduce this block diagram into what we have got from here. We have got this GS upon 1 plus minus HS GS. Okay, just GS upon 1 plus minus HS GS. CS is your output, RS is your input. Okay, so we have just reduced this transfer function after eliminating the summing point in a closed loop system. Okay, there is a small mistake over here. You can see that when we have transferred this value on the left side, this plus minus should become minus plus over here. Okay, minus plus. Similarly here minus plus. Similarly here this will give you minus plus. Okay, now we have just eliminated the summing point in this block diagram. What next we are going to do, if we have a unity feedback control system. Okay, unity feedback control system means we are just going to do some addition in this block diagram. You can very easily understand this. If we have a very unity feedback system, if you have unity feedback system, we don't have this, we just have this single line. Okay, so this is the unity feedback system. Okay, so what we can do over here? We can do over here that we don't have we have HS is equals to 1. So if we put HS is equals to 1 in this, then the output should be according to this block diagram. So here HS is given, so just change it. So after simplifying the whole equations, we will get this as a transfer function, that is GS upon 1 minus plus of GS, if we have a unity feedback control system. Alright, so this is so simple in this. So let's move further now. So if we are going to relate the transfer function relating ES and RS, you can see what is ES. ES is here, the error, and what RS is here. Okay, if we are going to have the transfer function relating both these, then how we can do? You can see that from the above block diagram, you can very easily determine that ES is simply the error which is showing RS plus minus BS over there. Okay, and BS is what? BS is simply what? BS is simply CS into HS. Okay, CS into HS. So very easily we can do this. Substituting the value of BS in this above equation, we will get ES is equals to RS plus minus CS HS. Okay, CS is what? CS is equals to ES into GS. From the same block diagram, if you see, let's draw roughly that block diagram over here, so it will easily this is HS, this is GS, okay, this is RS, this is BS, and this is ES over here, the error. This is the output CS over here. Okay, so this is a simple block diagram. So from here you can see that CS should be equals to what? ES into GS, ES into GS. Okay, now substituting the value of CS, okay, in the above equation, in this above equation. Okay, so what will get? ES is equals to RS plus minus ES into GS HS. Okay, so from here RS is there, Okay, so after simplifying this equation, you can see that ES is here, ES is also in this. So let's take the common, then ES upon RS very easily can come out to be ES upon RS come out to be 1 divided by 1 minus plus GS into HS. This simply represents the transfer function using ES and the RS. Okay, ES is simply what? The error, and RS is what? Input. Okay, so this represents the transfer function using both of these quantities. Okay, thank you. Sorry, one more point is left. No, this is the last point. When two or more inputs act on a system, the total output is obtained by adding the effect of each individual input separately. Okay, so let's see how this is happening. This is a summation point in which both of the inputs are there. Okay, first one is R1S, second one is R2S. Okay, these two inputs are there acting simultaneously on one system, that is GS is the transfer function of this control system, and CS is simply the output. Okay, we can simplify this and we can take the individual output of both the system. Okay, so if you are going to consider R1S, then you can see GS is there, CS is the output. Let's consider C1S if we are considering R1S over here. Okay, R1S, GS is the transfer function, C1S is the output of this. If we are considering R2S, the second input, okay, we are getting C2S. Okay, considering R2 as the input. So you can see it very easily. If you are considering the first case, then the output can the input output relationship can be represented by C1S is equals to R1S GS. Okay, in a similar manner you can see that C2S is equals to R2S GS. Okay, all right, the total output should be what? Total output will be what? CS, which will be C1S plus C2S. Okay, and this will give you, CS will give you R1S GS plus R2S GS. So this is the total output when two individual inputs are acting on one transfer function. Okay, so that's all about the block diagram representation. I hope you understand. For any problem, kindly ask me. Thank you. Thanks a lot.